Yo, what up, calculus students? We're into Unit 4 where we talked about EDX. Kind of reviewed derivative rules as well as function analysis with EDX, who has its own derivative rule that the rate of change of EDX is itself. It's kind of confusing to students, but once we change it, make it e to the x squared, what's very important is that you're not really using the power rule. You're not really like bringing down the x squared, rather it's a chain. And we introduced the concept of like e to a power being like an outside chain. So I have a 2x, I have an e to a power. So this slope is e to the what starts in the parentheses stays in the parentheses times 2x. Cool. And we did all sorts of function analysis. We factored out e to the x a lot, and we're good. Then we talked about its inverse, the natural log of x, whose slopes are 1 over x. And that really introduced us with just don't forget, if you ever have log of e to a power, it's just the power. We use the ideas of plugging in correct values as test points. But this kind of introduced us to like inverses in general, how like e's slopes had to deal with its y values. Log slopes, the inverse, had to deal with its x values, but it was a reciprocal. And we introduced that if you have a point f that has a point a, b, so f of a equals b, and let's say the slope is c, that the inverse would have the flip-flop point. F of a equals b, f inverse of b would have to go back to a. We would undo what's being done. And the slope of the inverse at this point, which is where the x coordinate is b, that would be the reciprocal of the slope at a. So like we would have the slope of the inverse is this reciprocal of the slope of the original at the y coordinate that it's kind of corresponds with. So anyways, just remember this, and that kind of leads you to glory. And then we talked about tangent approximations, like what else can we do with a tangent line besides look at it? Well, if you have, say, a curve and you zoom in on the curve, curves look straight. So understanding that lines are like, if you zoom in on curves, they look like lines. We can approximate y coordinates on curves by using a y coordinate on a line. What we say is like, oh, here, this is a point f of 2 equals 3. So let's call this x equals 2. Let's say I'm trying to approximate f of 2.1. Oh, maybe you don't know that, but maybe you know that the slope of the tangent at 2 is 4. Cool. Well, you'd say that the function at 2.1 can be approximated by the tangent line, and the equation of this tangent line is y minus 3 equals 4 times x minus 2, can be approximated by the y coordinate on the tangent line. So like this is the y coordinate on the curve, which is like this point right here on the black curve. The y on the curve can be approximated by the y on the line, on the tangent line, which is, I'll say y of 2.1. And that equals, you could just solve for y here. 4 times 2.1 minus 2 plus 3. So that's 4 times 0.1 plus 3. So that's 3.4. So we would say that this y coordinate on the line is 3.4, and that's going to be approximately the same as this y coordinate on the curve. Other things we need to know is that based on concavity, whether our approximations are over or under, we can see that since this curve is curving downward, which we know by the second derivative, if the second derivative is negative or curve is curving downward, tangent line values are going to be above the actual. These would be over approximations, or the actual has to be under the approximation. All right, let's get to the questions in Unit 4, which I will do right now. There you go. This is hard. What's going on here? All right. So O and I got a log, I got x squared, 1 over parentheses 2x. Hold on, my wife is blowing me up right now. And it could be about our plumbing. Oh, shit. Okay. We have serious plumbing issues in our addition of our house. So we got 1 over x squared times 2x. We can cancel the x's if we want to, because this just can go up top and say it's 2x over x squared. Since it's multiplication, you can simplify. You get 2 over x. You plug in e squared, you have 2 over e squared. Look. What's h? Well, let's just like take the derivative of this. This is very much like a notational derivative, like a table problem. Just know that the slopes of f are f slopes. So g prime is f prime of x times e to the f of x. Cool. Now let's go ahead and take the derivative of this. Now here it is. I don't know why with all these review problems, we always have this like combination of chain and product, but it's good. We'd have the slopes of the first, which would be second derivative, the slopes of the slopes, times the second, plus the slopes of the second we just found is f prime of x times e to the f of x. That's the slopes of the second times the first, which is an f prime, which means we got this f double prime x, and then we got this f prime squared. And if you factor out the e to the f of x, which we do often with e and its derivatives, we have this f double prime x plus f prime squared. That was fun. All right, chain rule with e, o and I, e to a power, and then the power. E to a power slopes or e to the power. I slopes I can rewrite as x to the negative first or use the quotient rule. I get negative 1 x to the negative second. So I get e to the 1 over x times negative 1 over x squared. So that could be simplified to be negative e to the 1 over x squared. Cool. Now, just remember that, because this is like a tough question that a lot of students think about. This was an average rate of change. It becomes an instantaneous rate of change if you say a limit as x1 approaches x2. As the 2 points get closer to each other, all of a sudden now we have an instantaneous rate of change. Now, what happens when x1 approaches x2 is that y1 is going to approach y2. What is going to happen is you're going to get 0 over 0 if you said x1 equals x2. Whenever you're seeing like what this stuff is and you see this limit, you should say like which one of these is a derivative, which one of these is a derivative at e. We should be seeing like a 0 over 0. Okay, so like if you plugged in 0 for h for all of these, I bet you one of them, might be two, but one of them is going to give you a 0 over 0, at least one. So let's start. If I plugged in 0 for h here, I get e to the x over 0. That's like a vertical asymptote. That's not really going to be like a hole that we're looking for. If I plug in 0, I get e to the x minus 1 over 0. That's not it. If I plug in 0, I get e to the x minus e to the e over 0. That's not it. If I plug in 0, I get e to the e minus e to the e over h. So this is a possible one here. If I plug in 0 here, I get e to the e minus e over 8. That's not it. That's it. This is it. So we can see that my x distance is getting closer to 0. Cool. Here's my x distance getting closer to 0. Here's my y2 minus my y1. They're approaching the same thing, which is like they're approaching the same y value as h approaches 0. So there you go. That's the one. Okay, O and I, but this is a little bit trickier because I'm probably going to either use the quotient rule or rewrite. I'm going to rewrite because it's going to be easier to take the derivative of 1 minus x to the negative first. But that also involves a chain. Let's just go ahead and do the quotient rule. Let's do the quotient rule just to make sure we're good with that. Slopes of the top are 0 times the bottom, and don't care, minus the slopes of the bottom times the top, all over the bottom squared. So we get a minus a negative, so this is plus a positive. Sorry, that should be a 1 minus x squared like that. So we get 1 over 1 minus x times 1 over 1 minus x squared. If you have 1 over 1 minus x times 1 over 1 minus x squared, you'll have 1 over 1 minus x cubed. What? Oh, shoot. I bet you one of y'all made this mistake. It's 1 over what starts in the parentheses stays in the parentheses. Yo, my bad. So that becomes multiplied by the reciprocal, 1 minus x in the numerator. This is 1 minus x squared in the denominator, which means one of these 1 minus x squareds, or one of these 1 minus x's will cancel, and you get that. Look at that. Hey, look, another product slash chain. Why does this? I don't know. Like, I remember one of your AP classrooms, it had so many product slash chains. There won't be that many on the test. There might be one, might be two, but not like 5, 6, 7. Slopes of the first times the second plus the slopes of the second. Oh, and I it log x squared. We just did it, right? We had it earlier. It's 1 over x squared times 2x, which is 2 over x. That's the slopes of the second times the first. Thank goodness I don't have to take a second derivative. We get that. Product rule, slopes of the first times the second plus the slopes of the second times the first. What do you have to do often? You have to factor out. Yeah, I probably would have said, when is this increasing? Like, you don't see questions like this much anymore. You have an extra step. Like, when is this increasing? Or when is this increasing? So we need to do an analysis of this. Just be prepared. You have y prime. You have your critical points at -2 and 0. You know e to the x is always positive. It can be ignored. We'll have positives, negatives, positives. So we are increasing for x's less than -2 and for x's greater than 0. What about this situation? Slopes of the top times the bottom minus the slopes of the bottom times the top, all over the bottom squared. 1 minus log x over x squared is y prime. When does this equal 0? Well, for log x, we would start at 0 because you're not allowed to plug in 0 or anything negative. And you'd have to solve this equation 1 minus log x equals 0, which is when 1 equals log x, e to a power both sides, x equals e. So we would look at x equals e. I'd plug in something like e squared. I'd plug in something like e to the -3rd. Why? Because my derivative involves a log, which means I'm not going to know what the log of any value is unless it's an e to a power. I mean, I could guess. If I plugged in e squared, it'd be 1 minus 2. That'd be negative. If I plug in e to the negative 3, it'd be 1 minus negative 3, which would be positive. The denominator will be positive because of the square. So boom, 0 to e. Like this is what I would be asking you on your test. Okay, well, f prime is e to the x. F prime at 2 is e squared. The log of f prime of 2 would be the log of e squared, which is 2. This is an outside, middle, inside. No, the middle is the square. The inside is the tangent. Yeah, try that one out, exercise, guys. The more I do these problems that we're doing, the more I'm like, you guys should probably do your AP classroom questions. They're better. These are good questions, but they're not great. Oh, could be that one. It's that one. What starts in the parentheses stays in the parentheses. What started in the square is the tangent. What started in the e to the parentheses was tangent squared. Yeah. Hey, quotient rule, slopes of the top. Don't forget the derivative of the inside times the bottom, minus the slopes of the bottom times the top, all over the bottom squared. Looks like we got some simplification going on here. I have 4x e to the 2x minus 2 e to the 2x over 4x squared. Divide the top and bottom everything by 2. Or, guys, this is what I'm talking about with simplification. Factor to create a product. Now you can cancel or divide the top and bottom by 2. Factor out the e to the 2x, and you get 2x minus 1 over 2x squared. Remember the derivative of arctangent? Arctangent's derivative, arctangent parentheses, is 1 over 1 plus x squared or parentheses squared. The derivative of cosine is negative sine. Don't forget that. I'd have 1 over 1 plus what starts in the parentheses stays in the parentheses times negative sine. I hope we don't have any crazy things going on. We don't. All right, at x equals 0, what's going on? Well, I have my derivative is 2x plus negative 2 e to the negative 2x. Cool. What's my derivative at 0? Does it equal 0? Do I have to do some analysis? Well, I have 0 plus negative 2 e to the 0. The derivative at 0 is negative 2. What does that tell me? F is decreasing by 2 y's per x at x equals 0. A slope tells me how quickly things are changing. Oh, cool. We kind of did this. That's the answer. I'll do it again. Slopes of the top times the bottom minus the slopes of the bottom times the top, all over the bottom squared. We would then set this equal to 0 to find our critical points, and then we would do a sign analysis to figure out when we are increasing or decreasing. We would have that x has to equal e, or 1 equals log x, e to the power of both sides, x equals e. We'd start at 0. We go to e. This is f prime. If I plug something in like e to the negative second, it's 1 minus negative 2. This is a positive. If I plug in something like e cubed, it'd be 1 minus 3. Cool. Here's another function analysis. Good. I'm glad we got some function analysis ones. Slopes of the first times the second plus the slopes of the second times the first. When does this equal 0? It's a log x plus 1. When does that equal 0? That's when log x equals negative 1. E to the power of both sides, that's when x equals e to the negative first, or 1 over e. Okay, now here's the tricky part. Um, it asks you for the minimum value. We're not going to really be asked this on your midterm. We will talk more about overall minimums and overall maximums more next unit. But since it's value, we're talking about the Y value. I'm probably going to ask you, like, where do we have a minimum? Like, what X coordinate is there a minimum out? Here is my derivative right here. I will plug in something like e to the negative second, get a negative. I'll plug in something like e squared, get a positive. So this is the location of the minimum. But what this question is asking you is what the minimum value is. So this is an x equals location of the min on f, because f is going to decrease than increase. And the value means go ahead and plug in e to the negative first into the original equation, which is e to the negative first times the natural log of e to the negative first, which is negative. Well, cool. Great question. Just a simple function analysis of e to the x times stuff. I literally think we did this question earlier, but set it equal to 0 to find your critical points. You have a critical point at -2 and 0. You then do further analysis to figure out if there's maxes and mins, plus, negative, plus we did earlier because this is positive, and we are decreasing from -2 to 0. Very quick. Cool. More function analysis. Good. Good to see. Not many graph questions. If I'm doing anything in class today, with my randomized problems that I'm giving you every like 5 to 10 minutes, I'm giving you graph questions. I'm giving you problems that you haven't seen through this review packet. And then be like, yo, if you don't know how to do these problems, you need to go back into the unit review, which I posted with all the answer videos right next to your thing, and you need to really work on those types of problems that you might not see very many of, like graphs of f prime problems in this review. So again, it's like it's got to keep up. If you kept concepts in your brain, you're in good shape. If you kept processes in your brain, you're probably like, I forgot everything. What about e to the negative x? It's still positive. It's just a fraction. You need a coefficient to make it negative. You need to flip that e to the x graph. E to the negative x just makes it a horizontal reflection, which makes it a decay. So positives, negatives, positives still. When is f increasing? Whoop. Yoink. Did I factor wrong? That? Slopes of the first times the second plus, oh, there's a negative thing there. Shoot! I'm going to factor out a negative, which makes this a negative. Keeps these are positives. Oh. Listen, if you know what you're doing, guys, and you don't get the answer that you expect, you did something wrong. It's not, and you should go back and fix it. Versus saying, oh, it looks like it's this answer, you know? Go back and fix it. Don't don't give up and say, oh, I don't know what I'm doing. You do know what you're doing. You know what you're doing. Just you might have made a little mistake along the way, like I did. I just made a little mistake along the way. I still know what I'm doing. I'm going to go back and fix it. This is very, very important on the AP exam. You know what you're doing. If you don't get the answer you're looking for, you probably made a mistake somewhere. Now things are different. We do have this negative out in front, which means this is a negative here. That's a big fat negative value. So this would be a positive, positive, negative, positive, negative. We're increasing between -1 and 3. Completely different from what I saw first. All right, now we get to a problem and we see inverses, 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 inverses. Throw out your knowledge of inverses. AB, the slope of A is C. We're talking about G, which is F inverse. BA, G prime when the X value is B is 1 over C. I'm trying to find G prime when its X value is 2. 2, 2, 2. I need to find F's slope when its Y value is 2. Oh, that's F's slope at 1 because you were told G of 2 is equal to 1. They literally gave you G of 2 is 1. So now I need to find F's slope at 1, and I'll know G's slope at 2. F's slope is 3x squared plus 1. F's slope at 1 is 4. This is 4. This is 1/4. That's how it works. Okay, we got F and G. G is the inverse of F. I'm trying to find G prime at -2. Okay, so let's just put our table down so I understand inverses and their slopes. We got, like Y's over X's would be B's over A's. Well, if inverses have flip-flop points, then Y's over X's would be A's over B's. What's the relationship between B's over A's and A's over B's? Reciprocals of each other. It's like very easy to understand. As long as you don't use X's or Y's, All right, so I'm told what is G prime of -2. So this is -2. This is -2. I need F prime when the Y coordinate is -2. I have G of -2 is 5. Okay, so this is 5, which means this is 5. So if you tell me F's slope at 5, I will know G's slope at -2. Well, F's slope at 5 is -0.5, which means G's slope at -2 is -2. It's not opposite reciprocals. It's not perpendicular. They're just reciprocals. B's over A's, A's over B's. -2. Approximate this value obtained from the tangent of the graph at x equals 0. Okay, well, if I plug in x equals 0 to get the y coordinate, I get 2. Square root of 4 is 2. I need the slope. I got to O and I it. I have a 1/2 power and I have a 4 plus sine x. 1/2 is 1/2 parentheses to the -1/2. 4 sine x is just cos x. So the slope equation is 1/2 4 plus sine x to the -1/2 times the cosine of x. And I need a slope at 0. So that's 1 over 2 times 1 over the square root of 4 times 1. So I get a fourth. So I have y minus 2 equals 1/4 x minus 0 as the line that will approximate the curve around x equals 0. And that's what it means. You're going to get a y on the line to approximate a y on the curve. So the y on the curve, so I'll probably use the function notation. This is the y on the curve, can be approximated with the y on the line, which is 1/4 times 0.12 plus 2. Now, how do I do this? Actually, it's the one situation where it might be easier to change to fractions. It's tenths, hundredths. So this is 12 hundredths. So I can divide the top and bottom by 4 and gives me 3 100ths plus 2. So that's 2.03. Look at that. And the slope of arc sine is sine inverse. Slopes are 1 over root 1 minus x squared. I think I showed you like very briefly why that's the case on a homework. So anyways, I'll get 2 over, 1 minus 2x squared. It's like, let's not be sloppy here. It's sine inverse parentheses. It's 1 over root 1 minus parentheses squared. So it'd be 1 over root 1 minus 2x squared times 2. So that's 4x squared times 2. It's a positive. And that's unit 4. A decent sample of unit 4. All right, peace.